Hey guys, today we're going to be talking about our applications for our absolute value functions. So in other words, we're going to be kind of talking about some real world situations for these. Okay, so let's take a look at number one. I thought a football example would be pretty appropriate since it's football season. Number one says yard lines of a football field have the relationship shown in the table below. So we all know this. If you start at one end zone, you walk to the other side, it goes 10, 20, 30, 40, 50. Now, as you get farther away, it's 60, 70, 90, 100. You're that many yards away from one end zone. However, the football field lines start going back down the other side, right? And so that is actually an absolute value relationship. So let's see that absolute value relationship here. So if we take a look at this, I want you to come down here to the graph and we're going to label it. So this is going to be my x, of course. Oops. So this, of course, is going to be my x, and this will be my y. We're going to use x to represent the distance from one end zone to the other, and we're going to use y to represent the marked yard line. All right, then we're going to label some points on here. So let's start here. Of course, this is 0, 0, right? And then we're going to have a point at, we're going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we're going to count by tens instead of counting by ones, since we're using a lot of tens here. Then we're going to go, same thing up here, 20, 40, 60, 80, and so on. Okay, then let's go through here and let's put points on for each one. So if this is my x, this is my y, I'm going to have a point on my graph at 0, 0. So that's when I'm 0 yards away from one end zone. We're also at the goal line, or the 0 yard line. Okay? Then we'll have a point at 10, 10, a point at 20, 20, a point at 30, 30, a point at 40, 40, and a point at 50, 50. But then, just like an absolute value problem, we're going to hit a vertex, and we're going to start coming back down the other side. So next up, we'll have a point at 60, 40, 70, 30, 80, 20, 90, 10, and then 100, we get to the other goal line. When we're 100 yards away from one goal line, we're at the other goal line. So you can see my graph here. Now, don't put arrows on it, because then the field would just go on for infinity. And you'd be like, not even be able to see the players. They just keep on going. So we need to first, though, write an equation for this. Now, it's really quite simple. We can see that that is my vertex, right? We have a vertex of 50, 50. And so I can write my equation. That means my h is 50. That means my k is 50. However, I am missing what my a is. So to find my a, remember what we do. We are going to count on your graph and see. So to find my a, we're going to go down 1, and then we go out 1, or down 10, out 10. So my a is going to be, first off, it's negative, because my graph is opening down, and it's going to be 10 over 10. Well, my a is negative 10 over 10, but that, of course, just reduces to negative 1. So my a is going to be negative 1. And then once I know what my a, my h, and my k is, I can plug it into my equation. Remember, our normal equation is y equals a times x minus h plus k. Well, we're going to rewrite it like this. We're going to go f of x. Remember, you can use f of x or y. It doesn't matter. For this problem, we're using f of x. I'm going to go f of x equals negative 1 in front times x minus 50, because it's a liar to what h normally is, plus 50. And there is my equation. Okay? And that represents that. Okay. On number 2, we have a really cool question. It says, you are trying to make a hole-in-one on the golf green shown below. Imagine that a coordinate plane is placed over the golf green. The golf ball is at the point 2, 2, and the hole is at 8, 2. You are going to bank the ball off the side of the wall of the green at 6, 8. So let's label some points. First off, my ball right here is going to be at 2, 2. Okay, that makes sense. Then the whole over here is going to be at 8, 2, right? So we're going to have our ball, have the hole on the other side, and then I also, at my vertex where it bounces off the wall, we're going to have a point at 6, 8. Okay, so if we're trying to write an equation for this, we already have a lot of information. I already know that my vertex is at 6, 8. So that means that my h is 6 and my k is 8. All right, so my h is 6 and my k is going to be 8. Now, can I tell what my a is going to be? That's always the question, isn't it? Well, I could count up and over, just like we can with our slope. But I want you to understand we can also use the slope formula. And my slope formula, remember, is y2 minus y1 divided by x2 minus x1. So we can label these points. We can say, oh, this is going to be x1 and y1, and this will be x2 and y2. And then I can plug this in over here. I can go, my slope for this piece is going to be 8 minus 2 over 6 minus 2. And of course, 8 minus 2 is 6, 6 minus 2 is 4, and then 6 fourths reduces to 3 over 2. So my A is going to be 3 over 2. However, don't get fooled here. Yes, this piece is positive, right? And you're right, it has a positive slope. But we were just finding the slope of that to be able to find what my A is. But we cannot forget that my A is negative, okay? Because it opens down. So we're going to say that this is negative 3 over 2, okay? Because your A is not quite the same as your slope. We can use the slope to find what your A is, but A is not quite the same as what our slope is. Okay, so now we're here. Here's what we can do. We're going to plug this in. So I'm going to go, my equation is going to be y equals negative 3 over 2 times the absolute value of x minus 6 plus 8. And there is my absolute value equation. However, next up here, what we're going to do is we're going to see if we make the shot. The way we can tell is if we take this, the hole, if we take that hole right there and plug it in, does it actually make sense to be on the graph? Does it work? Well, let's see. Remember, this is my x and my y. I'm going to take the 2, I'm going to plug it in for that y right there. So I'm going to go 2 equals negative 3 over 2 times the absolute value of 8 minus 6 plus 8. Well, 8 minus 6 is, of course, 2. Now, 3 over 2 times 2 is just 3. And then 3 plus 8 is, oh, wow, okay. Well, it's just going to be, honestly, guys, it's just going to be 11. So, does 2 equal 11? No. No, it certainly does not. So, is this point a point on my graph? No, it isn't. So, do we make a shot? No, we do not. No, we don't. The hole is not on the graph. Now, you could also take these 2 points and use them to find the slope. If the slope matches, then it would be correct. Because remember, guys, your graph, you know, they can both be down, they can both be up, but they can't be like this. They have to be symmetrical. Okay, so what does A represent in real-world situations? A represents the rate of change. How much we go up over time or how much things change at a distance. All right? Okay, let's turn the page here and let's write an absolute value equation for these situations. So, if I have these situations here, we have 2 points. We have -6 and -2. If I wanted to write an equation for those points, what could I do? Well, we have this little formula up here. So this little formula right here is very, very helpful. And what we're going to be doing is we're going to be starting with the answers and we're writing the equations for those answers. So it's a little bit back to what we did last chapter. But let's take a look at this first one. We have -6 and -2. Let me show you the trick. So we go x minus the halfway point. Well, the halfway point between -6 and -2 is -4. So we're going to go the absolute value of x minus -4 equals, well, the distance from the halfway point. So there's my halfway point. To get from -4 to -2, we have a distance of 2. And the same thing this way. So that one's going to be 2. And then we can simplify it. If we're minusing a negative, that's going to be plus. So we're going to have x plus 4 equals 2. Now, that is my answer here, okay? That is my answer here. We have x plus 4 equals 2. But what we're going to need to do is let's go ahead and check and make sure that that works. So if I have this equation of x plus absolute value of x plus 4 equals 2, remember, to solve an absolute value, we split it in half. We're going to have x plus 4 equals positive 2 and x plus 4 equals negative 2. If I minus 4 to both sides here, we get x equals negative 2. If I minus 4 to both sides here, we get x equals negative 6. Those are my two answers. Hey, look, those are the same answers that we started off with. So this is how we can write equations to represent two numbers. And so that way we can see the range. Let's take a look at number 4. So number 4, we're going to have to write absolute value of x minus a number that's in the middle equals the distance from that number. But how can we tell? How can we tell what that number is? Well, you could very easily see on this one that it's 2. But let me show you a trick to be able to find it. You can find the average between those two numbers. So all you have to do is go -2 plus 6, and then whatever that is, divided by 2. -2 plus 6 is 4. 4 over 2 is, hey, you guessed it, it's 2. And so that's my middle number right there. So we're going to go x minus 2 equals the distance here. So that's 2, 4. My distance is 4 from that center to the outside edges. And then that's just my equation. X, absolute value of x minus 2 equals 4. That's how it works. So what if we have a word problem like number 5? Number 5 says all real numbers exactly 4 units from 7. So 7 is the middle. So we'll go x minus 7. That's our middle spot, right? From 7. And then exactly 4 units, that's how big of a gap is between the two. And so that would be my equation. Guys, listen, if you have a point at 7 and we're 4 units this way, that would be 11. And if we're 4 units this way, that would be 3. Hey, so there you go. This equation would give us, if we worked it out, it would give us 3 and 11. Okay, now what if I have inequalities? Well, with an inequality, the thing that you have to keep in mind is this. There's two types of inequalities. There's less than, okay? And remember, that's like this or like this. And that is always when the graph comes together. So if your graph comes together, that's a less than problem. So you're going to use one of these. Now, remember, you use this one for open circles, this one for closed circles, right? Okay, now, what if it's greater? If it's greater, that's greater than or equal to, you're going to use, once again, this one you're going to use, we're going to go apart. So if you're going apart, you're going to use a greater than symbol. If you're coming together, it's an and. You're going to use a less than symbol. Okay, so now, for this one, we're in between -4 and 2. So how do I do this? Well, remember, find your center. So to find my center here, we can add -4 plus 2 divided by 2. That equals -1. So my center is going to be -1. So we're going to have x minus -1. And then we have to decide, is this less than or greater than? Is it less than or equal to or greater than or equal to? Well, it comes together. So this one is a and. And we have closed circles. So this one's going to be less than or equal to, and then the distance, if this is -1, my distance here is 3, and my distance here is 3. Then I can just simplify it. It's going to be the absolute value of x plus 1 is less than or equal to 3. Okay, next one up. We got to find the middle between -2 and 12. All right, so if we add the two together and divide by 2, the middle is going to be 5. All right, and so the distance, so we're going to have, and it's an or, so we're going to go x minus 5 is greater than, not equal to because we have open circles, and it's greater than because it's going apart. Is greater than, what's the distance between 5 and 12? Well, the distance between 5 and 12 is 7, and the distance between 5 and -2 is 7. So it's going to be x minus 5, absolute value of x minus 5 is greater than 7. All right, number 8 here. A number is less than 6 units from 0. Okay, so here's your key, less than. All right, so we got a less than symbol. From 0, that's my middle, so we're going to go x minus 0 is less than, and it's 6 units apart from those two. All right, perfect. Now that minus 0, we could just get rid of it, and we can just say the absolute value of x is less than 0. Unless less than 6. In other words, it's going to be between 6 and -6, right? Just like we learned before. But this one's an and, it's going to come together. All right, number 9. The rules for an essay contest say that entries can have 500 words with a tolerance of at most 30 words. Now, tolerance means an agreeable amount, so an amount that will still be counted. So if we go more than 30 words over, doesn't count. If we go less than 30 words over, doesn't count. So we have to be either at or in between that. So how do we write that out? Well, my middle is going to be 500. That's what we're aiming for, right? So we're going to go x minus 500, do the absolute value of that, and my tolerance, how much I can vary from that middle, is going to be 30. Now, we're going to be in between. So the highest we can do is 630, the lowest we can do is 570, right? So if we're in between, that's a less than, that's together. So it's going to be less than or equal to 30. And that's going to be my answer there. If you wanted to see that on the graph, it would be like 470 and 530. And we could even have closed circles here and connect in the middle. Okay? All right, guys, I hope this has been of help to you. Remember, our test is coming up. I hope you all have a great rest of your day. Thanks, guys.